Okay, this is 3.1 for Chapter 3 in Workplace Math 11. Chapter 3 is all about surface area, volume, and capacity. So for this section, we start off with surface area of prisms. However, to be able to calculate the surface area of prisms, you will need the following two-dimensional shapes. So we have squares, rectangles, parallelograms, triangles, circles, and trapezoids. Okay, so that we are looking at all of these different formulas and relationships and how to use each one. Okay, so this is just on your front page, just so that it's there for you to reference as you're going through. Note that you also have your formula sheet that is in the pink bin as well. Okay, so to start off easy, we simply calculate the area of each figure. So we notice this is a rectangle. A rectangle is the formula of area is equal to length times width. So this is equal to 6.8 centimeters times 4.5 centimeters, which gets us 30.6 centimeters squared. Notice it is centimeters squared because otherwise you would have centimeters times centimeters, which can be replaced with a squared. Then we're looking at B. B is a triangle, so the formula for area of a triangle is 1/2 base times height. So this is base, this is height. So we end up with 1/2 12.8 centimeters times 7.8 centimeters. We end up with an answer of 49.92 centimeters squared. A good rule of thumb is to take 2 decimal places if the decimal keeps going. So just a note. Okay, so it is there in writing as well. If the decimal has more than 2 numbers after it, round to 2 decimal places. So then we notice we have a parallelogram. The formula for a parallelogram is A is equal to base times height. There is your base, there is your height. So we end up with 3.1 meters times 2.1 meters, and we end up with 6.51 meters squared. Okay, so you can try to build your skills on page 127, numbers 1 and 2, A to C for each one. Come back when you're done. Okay, so that is dealing with regular shapes where you have a formula. But now what do you do when you have a shape that's like this? It's not regular. It's not easy peasy, just one formula done. When you have a shape that is made up of a whole bunch of regular shapes, you can split them into the shapes that they're made up of. So for example, I can split this one here, and I have a triangle. Okay, note that my height would be 12.6. My base would be 6.8 plus 3.1. Okay, because it is this side and this side long. Okay, then we have this one, which would be 6.2 and 3.1. And then we have the bottom one, which would be 13.4 and 6.8. With that, we can calculate our area for each one if we treat this one as A1, this one as A2, and this one with A3. So we can do A1, the formula is base times height, not base times height, length times width, same thing. Okay. So we have 6.2 centimeters times 3.1 centimeters, and we get an answer of 19.22 centimeters squared. A2, we get 6.8 times 13.4. We get an answer of 91.12 centimeters squared. And then A3, we have 1/2 base times height, which is equal to 1/2 9.9 times 12.6. So we get an answer of 62.37 centimeters squared. But now that we've calculated those three areas separately, what do we have to do with the three numbers? Well, altogether, those three numbers make up the shape that we were looking for. So to do that, we would go and take our numbers and add them together. So 19.22 centimeters squared, 91.12 centimeters squared. Fix that. And 62.37 centimeters squared. Add them together, and you get a total area of 172.71 centimeters squared. Okay, so that would be your total answer. 172.71 is your total area for this whole shape. Okay. If we give it a try and try numbers 3 and 4, come back when you're done. Okay, so what do we do when we're working with the surface area of prisms? First off, we need to make sure we know what a prism is. So a prism is a three-dimensional object with ends, which are called bases, that are congruent and parallel. Okay, so that means that they are the same and they are parallel, so they run in the exact same direction. And then sides, which are called faces, that are parallelograms. Okay. So prisms are actually named according to the shape of their base. So if it is a rectangle on the bottom, it is a rectangular prism. If it is a hexagon on the bottom, it is a hexagonal prism. If it is a triangle on the bottom, it is a triangular prism. Okay, so that's pretty straightforward in how they're named. So you can try number 5 on page 133. Come back when you're done. Okay, so when it comes to dealing with prisms, one thing that can be very helpful is being able to draw the net. Okay, this helps you visualize the sides individually as opposed to the shape as a whole, and it allows you to be able to calculate the area of each side without having to visualize where it would be on the shape. So all a net is these shapes that you've probably experienced before, where you would use them to cut out and make 3D objects. Yeah, we've all done that in art class. Okay, so you can go ahead and try page 135, numbers 6 and 7. Okay, moving on. So now that we have the nets, how do we draw them and how do we find the area? So if I have a rectangular prism, I know I have a whole bunch of sides. Doesn't have to be perfect. That's actually really bad, but no, that's bad. Yeah, that's a bit better. Not great, but a bit better. Okay. what we can do is we can take our diagram and split it up. Okay, so if we keep our 1.9 and our 3.8, so if we do 1.9, that means that this is also 1.9, and this is also 1.9. This is also 1.9. That also means that this is 1.9, because when you fold the shape up, that would become your top. So this is also 1.9. Okay. Then we are looking at this is 4.6, which means this is 4.6, and this is 4.6, and this is 4.6, and this is 4.6. That means that every side left is 3.8. So 3.8, 3.8, 3.8, 3.8, 3.8, 3.8, 3.8. So if we look at it, we have this one and this one that are the same. So we can call that area 1. We have this one and this one that are the same. We can call that area 2. And then we have this one and this one that are the same as well, and we can call those area 3. And what this does is it allows us to identify the sides and treat them each as their own rectangles. Identifying this area of a rectangle is easy. Okay, so we go area 1 is 1.9 times 3.8. Right? So 1.9 times 3.8. And to make it easier, we have 2 sides that are like that. So I'm going to put this in brackets and times it by 2. And we get an answer of 14.44 meters squared. Area 2, we have 1.9 times 4.6, and once again we have 2 sides that are that size. So times by 2. And we get an answer of 17.48 meters squared. Area 3, we have our 2 ones that are left, so 3.8 and 4.6. And once again, we have 2 sides that are like that, and we end up with 34.96 meters squared. But now we're in the same situation as we were before. We have 3 separate areas, but what do we do? Well, together, those areas make up the area of the rectangular prism. So what we have to do with these ones is we have to add them together. So when we add them together, we get 17.48, 14.44, and 34.96. Right, you add them together, you get 66.88. Remember to keep your units. So that would be our final answer. Okay, so split things up into their net, use their individual formulas to calculate the area of their sides, and then add the answers together at the end. Okay. So you can try build your skills on page 138, 139, number 8. Okay, just like how you had to deal with irregular shapes with 2 dimensionals, now what do you do if you have an irregular shape that's 3-dimensional? Well, pretty simple. Treat it as 2 separate things. So if we do this one as area 1, this one is area 2, we can figure out how long each of our sides are. So if this is 27, that means this is, and this is. So that is 27. We know that all together that is 48. However, that is only 45. And 78 minus 45 will get you your 33 for up there. So if we want to do that, we know that we have 2 sides that are identical for each one. So if we calculate out the area 1, we have 27 times 33. We have 2 of those. We have 55 times 27, and we have 2 of those. And we have 55 times 33, and we have 2 of those. So altogether, we should have 6 sides. So then if we go through, we get 1782. We get 2970, and we get 3630. Add those together and you get 8382 centimeters squared. Now do the same process for area 2. Pause the video, calculate it out, and then unpause when you're done and see if you got it right. Okay, I'm going to assume that you have paused the video, finished that question, and just checking to see if you are doing it correctly. So area 2. Okay, but now we've calculated each of the sides individually. However, there's one thing that we need to account for when we're dealing with shapes that are put together, is the sides that are in here. Okay, so those sides aren't showing, they don't count for surface area. So how big are those sides? They are 30 by 27. So if we take our two numbers, we need to add them together. So 8382 centimeters squared plus 6750 centimeters squared. But then we need to take away those two sides. So take away 230.30 times 27. Okay. We end up with a total area of 13,512 centimeters squared. And that is your final answer. Okay, so you can try build your skills numbers 9 and 10 and come back when you're done. Okay, I know this one is a lot of work, but we are going to keep going. So, Kareem has been hired to paint walls and ceiling of a living room in a house. The room is 22 feet long, 3.5 feet wide, and 8.5 feet high. There is one window that is 10.5 feet by 6 feet, two windows that are 3.5 feet by 2.5 feet, and two doors that are 2.5 feet by 8 feet. So what I'm going to do with this one is I'm going to split it. Okay, so this is area paint, total area. Okay. And then this is area not painted. Okay. So for example, the area not painted, the area not painted is like the windows, the doors, okay? Those aren't going to be painted. However, it's easier to treat the walls as rectangles and calculate them out that way than to try to do each of the individual calculations and break each one up into different squares and different rectangles, and it gets very complicated. So to do this, we are going to do 8.5, 8.5, 22.5, 13.5, and 13.5. So what this is we should have each combination. We should have 22.5 with 8.5, 22.5 with 13.5. We should have 13.5 with 8.5. Okay, so we need to have those three different combinations. Because what that allows us to do is it allows us to realize, okay, so 22 feet long, 8.5 feet high. Okay, so that's a wall, so we have two of those. 13.5 feet wide, 8.5 feet high. Okay, that's a wall, so we have two of those. And then The last one would be your ceiling, so we only have one of those. Okay. So remember to calculate area's length times width. So this would get us 382.5. This would get us 229.5, and this would get us 303.75. So altogether, if you add those up, you get 915.75 feet squared. So that means that the total area for wall space, including windows, doors, and everything, is 915.75 feet squared. So if we're looking at area that's not painted, we have one window that is 10.5 by 6. So 10.5 times 6, that gets us 63 feet squared. We have two windows that are 3.5 by 2.5. So two windows, 3.5 by 2.5. That gets us an area of 17.5 feet squared. And lastly, we have two doors that are 2.5 by 8 feet. Two doors, 2.5 by 8, which gets us an area of 40 feet squared. That gets us a total area that's not being painted of 120.5 feet squared. So if we have our total wall space, including everything, and our area not being painted, to find the area that's going to be painted, simply subtract or find the difference between the two numbers. So we have 915.75 feet squared minus 120.5 feet squared. So we end up with a total area being painted of 795.25 feet squared. And that would be your final answer. So if according to the calculations that we did above, 1 gallon of paint covers approximately 225 square feet, how many gallons does he need to buy? Okay, so if we take our 795.25 and we have, let's do it this way, times 1 gallon gets you 255 feet squared. Notice how I have feet here and feet here. Yes, it's a little more complicated to write it out this way, but all I've done is taken the conversion. The 1 gallon is equal to 255 feet. What that's going to do is that's going to cancel out those units, and all I'm going to be left with is gallons at the end. And all that really means I'm doing is 795.25 divided by 255, which gets us 3.5. However, you can't just buy half a gallon, okay? So we need to round it to the nearest whole number. But if he only buys 3, he's not going to be able to paint all the walls. So therefore, he needs to buy 4 gallons. However, now if paint costs $55.40 per gallon and he wants a profit of about $225, how much does he need to charge to paint the room? Okay. So if he has to buy 4 gallons at $55.40, okay, that is going to mean he is spending a total of $221.60 on paint. Okay. Plus, he wants to make a profit of $225. That means that he should charge approximately $446.60. Okay, so these calculations can be important when it comes down to how much do you charge to make something? How do you figure it out? Okay, so you can try page 145, numbers 11 and 12, and once you're done, you can move on to the practice your skills page 146 to 148, numbers 1 to 4. Remember, I have posted the answer key to the workbook on the Google Classroom for your reference as you're going through. If you're confused or not sure if you're doing it right, go in and check. Check to make sure you're getting the right answers. If you get an answer and you absolutely know it's right and you cannot figure out how they got the answer in the back of the book, come see me. I know there are a couple answers that are incorrect in the back of the book. However, that does not mean you automatically assume that the answer is incorrect in the back if you got something different. Okay? Come see me, ask for help, and we can figure it out together.